Today I'll be talking about the long-awaited graphical user interface. All right, I guess I'll start. I have a lot planned for today. So first, I'll go over briefly what a graphical user interface is. So it is a type of user interface that allows the user to interact with a program or piece of code through graphical elements, for example, buttons, windows, scroll bars, text boxes, etc. And the purpose of this is that it's more intuitive and it's more used to more similar to like what we're normally dealing with in regards to computers. And also it can be more compact and feature a more visually appealing design. But sometimes using a graphical user interface as opposed to normal command statements is that it can be less efficient because the computer has to have specific code behind every single graphical element within a program. So now that we know basically what a graphical user interface does, we have to understand and learn how to create a graphical user interface. Generally, this requires some sort of extension. Some programs, for example, have it directly, but others you have to download some sort of file or something. And there's a lot to it, so I don't think you guys will be able to follow along. However, I will be demonstrating how to create a graphical user interface to the best of my ability during this class, and I can post the graphical user interface extension that I'm using for BlueJ onto the Google Classroom if you guys have any interest in downloading it. And additionally, there are probably different graphical user interfaces you can use for different Java IDEs, for example, like Eclipse or IntelliJ. So I'm not sure because I have been using BlueJ to do my examples of graphical user interfaces. So the first example will be what we call the calculator example. You can see that a standard text box interface doesn't really work the best. When we think of a calculator, we think of something with like buttons and like pressing it rather than like typing in a statement into a text box, unless you're using like say Wolfram Alpha or something like that. Although I will mention that it is possible to create a calculator using the text box interface. It's just not as great. For example, like I can demonstrate it real quick, I guess. At least I'll try to demonstrate. I'll create some, I don't know, calculator program real quick. Shoot. Let's see if this code works. Okay, so this is what something would look like for like a simple addition calculator. At first, I tried to print out the addition statement, but something wasn't really working. So I don't know. I didn't feel like it was worth my time. So what this does is now is basically if you enter two numbers, it prints out the sum of it. But you can see like how this would be a representation of how a calculator will work in a standard text box interface. This is what we call when we just type into the program here. I don't know, you can make it more advanced by maybe asking another question. For example, please choose a mathematical command or something like that. And then outputting the statement after or something like that. This could definitely be more refined, but this gives an idea of how a calculator would work without buttons per se. However, this obviously isn't like something that is ideal when we think of a calculator, because when we think of a calculator, we want something like buttons. So this is where the graphical user interface part comes in. So I'll create a new project right here. Graphical. I don't know. So on this particular extension that I'm using, okay, hopefully it loaded, yeah. We get a program that looks like this. This designer tab basically allows us to design what the program will look like by adding various graphical user interface elements, for example, a button or a label or a panel or something like that, onto what we call the main field. So let's add a button, for example. When we add the button here, we see that it automatically generates the code for this button inside the code here. This button comes with a lot of what we call things that describe it. Since this button is an object class, when we create it, it has certain properties. Some of these properties include its initial color, its boundaries, which demonstrate how big it is, its font, and the text within it. Also, its visibility. Somewhere else should be its location, but I'm not sure. And we can see that these values change if we edit the button on here. For example, if we want to make it a square button, we can make it a square button. Or we can edit the size here to be like, I don't know, 80 by 80. So now I have a square button. You can see how this changes it. Okay, so the boundaries here define its location and its size. The 80 and 80, it's its size, and its location is 32, 82, relative to this top point, which is 0, 0. As it goes down in this instance, 82 pixels, and it goes across 32 pixels. See, if we move it up, it would be like 45 pixels. And yeah, so for the sake of consistency, I guess, I'll make the exact same program that we just did on REPL, but this time using what we call a graphical user interface. So I don't know, pretty simple, I guess. We create 2 buttons for the 2 numbers. And then maybe we create an equal sign at the bottom, and we want something to demonstrate what calculation is being done, I guess. So we edit this real quick, 32. Another square button, and this one can make like a 3rd square button for simplicity. See? Oh, I guess we need 9 buttons for every single possible digit, I guess. Yeah, that's how the calculator works. Whoops. Okay, we can just add buttons then. We can also do a copy and paste. Wait, can we not do copy and paste? I guess not. You can see that designing a graphical user interface is pretty tedious because you have to drag each component onto it. But it's better than editing the code directly because you cannot really control how it looks in the code because you don't have a visual of it. And this is what this designer thing allows us to do, I guess. I don't know what like an error sound is coming out. This could definitely be refined, as I said earlier, but we have all the buttons necessary and a label for the code. So now that we have all the graphical buttons and stuff within the program, we have to find out how to utilize it. So I'll save. We save this. And we have a project now. And we can see that this code is already readily generated for us, but we still have to know how to use it. So that goes on to the next part of my lesson. How do you get to the designer in BlueJ? For BlueJ specifically, you have to download a graphical user interface designer. There are other similar designers for other programming language, for other IDEs, for example, Eclipse or IntelliJ, but I will be posting The download file for my specific graphical user interface designer extension on Google Classroom if you are interested. Any other questions before I move on? What is the meeting ID? I don't know what the meeting. I posted it onto the Google Classroom earlier. I'm not sure if I can check currently. Yeah. So sorry, I guess. I'll move on real quick. Action listener. So what action listener is that it gives the button for the specific case of our calculator or any other graphical element a function. So basically what this means is that when you press the button, something happens. So how do we create a button, an action listener on a button? This would be a specific code example. And what happens is if we write this piece of code, what it does is that when the button 1 is pressed, this method name would be run. So I'll show an example of it, I guess. So say we want to add an action to button 1. We would do button 1 dot add action listener. Let me just copy this. So now we're, I don't know, say we want to create a method for finding some value, I guess, I don't know. We create a print statement, I guess. Display. So now, if we create a new function down here, we can change the label to display whatever number corresponds to our button 1. For example, button 1 would be 1 in our example, so we could do something like, let's see, label 1.set text. For a more complicated example of something you could do, we can refer to the program I showed at the very start of this course, which is, for example, I created a start game function, which involves setting the buttons to be invisible, changing their color, and etc. So you can do more complicated things, but for the sake of simplicity, I am merely displaying some number on the label. So I'm not sure if this will work, but it doesn't hurt to try. So now basically we have that pressing a button does something now. Before I said label, and when I press the button, it says 1 now. So this gives an accurate description of what happens when we press a button and how we were able to get that button to do something. So with this in mind, we can go on to creating a simple program for a calculator, I guess. First, we want to set the text of each of these to reflect what number they are. So instead of like button 1, we have like 1, button 0, 10 will be 0. Should be an equals sign. And in this instance, actually, I think it would be a much better idea to create an array of buttons. So I don't know. How can I do that? Actually, it wouldn't, because then the location of the button would be difficult to program in. I don't know. As you can see, this is like a really tedious process, but copy and pasting always helps. Shoot. So this will take some time, I guess, which isn't ideal, but it's not the end of the world. So while I'm doing this, which is basically just copying and pasting and doing what we did to button 1 to all the other buttons. Does anyone have any questions on how this process works? What is what? Oh, the meeting ID. Okay, the meeting ID is 937. I'll copy and paste it to you. Just use the link that I posted on Google Classroom. It's much more easier because if you use the meeting ID, you start to enter a passcode. And yeah, someone was asking me a question regarding the meeting ID, which is very kind of absurd. So I'll go back to doing what I was doing before. Okay, so now that we have, we want to apply this same function to multiple buttons, and different buttons have different properties, right? So the main property is that each of these buttons corresponds to a different number. So because of that, we have to create another what we call parameter for our function, which is int temp. We call it temporary. Yeah, sure. It's already on the slide. The code that I was copying and pasting repeatedly. Yep. So okay. Okay, so what I'm doing here is that I'm creating two variables for the two things that okay. How do I convert to a string again? That's a problem. Wait, whoops. Integer dot parse int. Oh, yeah. I'm kind of all over the place right now. So, whoops. Addition. So, would it be something like string dot parse a? Like that? Huh. Well, this is the basic idea is that we want to convert this to a string. I'll post the revised code when I figure it out on to Google Classroom, I guess. Because I don't know how to convert an integer to a string off the top of my head. Okay. We're creating this a graphical user interface representation of what we were dealing with earlier using a text editor. String. Integer dot to string. Okay, string dot value of. Okay, so this could work. And if it doesn't, the idea is there. So, well, I would have to debug it to figure out where it's not working, and hopefully I can get this to work. I'll post the solution on Classroom, but this is the idea behind how to use graphical user interfaces. It's a very tedious process, and we'll probably finish this up in our last meeting next week. So hopefully this is a good introduction to graphical user interfaces and how they can be good visual representations, but difficult to execute and inefficient.